This is for Year 12 methods and it looks at the product of functions. Again, if h of x is the name of the resultant function, it's f of x times g of x. Just like with the sum of functions, h will only exist where f and g both exist for them to be able to be multiplied to give you h. Therefore we have the rule the domain of h is equal to the domain of f intersect the domain of g. Let's consider h of x equaling x squared times e to the x. So in this particular case, x squared is f of x, and I've drawn that, and I've placed choice coordinates, and e of x is g of x. And this time we are multiplying the y coordinates together. I'll just move that up. The main lines I'm interested in are when y equals 0, because anything times 0 gives you 0. Now, neither of these functions equals 0 except at this point, and the exponential approaches 0 as x approaches negative infinity. And the other point that I'm really interested in is y equals 1, because when y equals 1, 1 times anything will give you that value. So they're the points that I'm going to look at first. Anything multiplied by 0 will give 0. Anything multiplied by 1 will give that value. Okay, when x equals 0, I can see that the parabola equals 0. So 0 times 1 gives 0. The only other values of 0 I have are all the way over here when x approaches negative infinity. That's going to be a value approaching 0 times a number that's really, really big, and it will give you a value that is approaching 0. Anything multiplied by something approaching 0 also approaches 0. And there are no other occasions when I have a y value of 0. Now I'm going to look for the occasions when y equals 1. There's one of them there. 1 times this blue curve will give that blue curve, because when it's times by 1 it's equal to the same thing. 1 times 0 will give 0. 1 times this blue curve will give the blue curve. Now, anything to the right of x equals 1, I've got a number bigger than 1 times a number bigger than 1 is going to give me a number much larger than those two numbers together. A number bigger than 1 times a number bigger than 1 is going to give me a larger number again. So I have a curve that is looking like this so far. Now, what's happening here? I have a large number like 4 times a very small number. It's going to somewhere, it's a bit hard to tell, somewhere in about there. So I have this approach occurring. That it's approaching the asymptote, because as x gets really small, the y value approaches 0, and times no matter what large y value you're multiplying it by, you're going to get 0. So this is what my product function will be, h of x equaling x squared times e to the x.